Okay, so the derived function. Alright, so let's travel back in time to last lesson, where we found by hand how to get the derivative, i.e. the gradient of a function. So we had our function that was a little bit like that. We chose 2 points on the line, P and Q. The x-coordinate for P was x, and this one was h units away, so x plus h. And then we found the y value of our function. We'll say this function is just f of x. So if our x-coordinate is x, that means our y-coordinate would be f of x. Same here, if our x-coordinate is x plus h, our y-coordinate would be f of x plus h. That means just subbing in the x value into the function to find the y value. That's just kind of the general way it goes. So what we saw is if we wanted to find the gradient of the chord that connects them, we did, so the gradient was y2 minus y1 over x2 minus x1, as it always is, which in this general term is f of x plus h minus that one, f of x, over x2, which is x plus h, and then minus that one. Right, this is all from last lesson. We've seen it before. What happens to this x and this minus x? Cancels out. So we're left with h on the bottom. Right, and how did we find the gradient of a single point on the line? If that was the gradient of the chord that connects P and Q, how do we find the gradient of the single point?
Wait, would you expand that out?
Sorry?
Would you expand that out?
No, we can't yet because we don't actually have the y values. This is a general term.
Is that when you find how close h gets to 0?
Yeah, because we want to get P and Q closer and closer together until they're a single point. So we do, as h approaches 0, we find the limit.
So you take h out.
Yeah, so the limit as h approaches 0 of this one gives us the gradient of point P, which is also what is that known as? Starts with a D.
Derivative.
Good. It's also the derivative of f of x. Okay, when we work out, so pretty much from now on, instead of doing all this jazz, like completely, you can just skip straight to that one there that's just over h, because we know that those x's are always going to cancel out. And doing it this way is called differentiation by first principles. So this is called So anytime you see a question that says find the derivative of this function using first principles, this is the method that you use. Pick 2 points on the line, h units apart. You chuck them into that little formula, find the limit as h approaches 0 until you get the derivative. Okay. So let's go into notation. So yeah. I've suddenly forgotten how to spell it. Derivative. Maths teacher. Okay, if your function is written in the form of f of x, then the derivative can't spell. Derivative is denoted by f dash x. If your function is in the form of y, so like y equals 2x plus 3, then the derivative will be found by dy dx. So I'll say like y in terms of x. i.e. y equals 2x plus 3. Similarly, if you've got a function like z equals 2s plus 8, how would you denote the derivative? Do you think if this one is y in terms of x and it's dy dx?
Oh, dz dx.
Yeah, you would say dz ds. Interesting to know as well that those d's are actually symbols. I wrote it down here. It means delta. I think it's Latin for difference. So you can't, like, it's not like a normal fraction where you cancel them out. It's just a symbol that means derivative.
Can you use a triangle?
Yeah, I thought that was cool.
Yeah, because the triangle.
Yes. Generally don't in maths use triangles.
No.
I think you can, because by first principles you got the change in y over the change in x and changes a triangle, but generally we don't see that in maths. Stick with the d's. So yeah, we usually say like dy dx and dz ds, depending on what letters you've got. Basically means the derivative of y in terms of x. Derivative of function y that's in terms of x. Okay, and if you've got just an expression on its own, such as 2x plus 3, so no y equals, no f of x equals, you just got the expression, then we would just say ddx.
DDX.
If it's a change in what though? If it's a change of a change in name.
Don't worry about all the changes and whatnot. That's just the symbol that we use to say derivative of this expression. It's just ddx. That's just what we say to mean derivative. Okay. So f dash x, if we've got the function in terms of like written as f of x equals blah, 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 then it's f dash x is the derivative. If it's y equals something, then it's dy d whatever other letter we've got. Same goes with if it's any other letter. And if it's just an expression, then we say d, and whatever letter is in that. So if it was 2x b plus 6, you say d db. Generally, it's y and x though, so don't worry too much about it.
So where does the 6 go?
Oh, we haven't actually. I'm just going through the notation for it. We're not actually solving anything. I'm just giving examples of the notation.
So Miss, our final answer would be like d over db equals something.
You'd write it like we'll go with this one. You'd write it as dy dx. Well, yeah. If you had y equals 2x plus 3, I haven't actually showed you how to get the derivative yet, but I just say dy dx equals 2. So the derivative equals 2. Okay. Okay, so that's our notation. Now we'll try the are we up to the example yet? Example. Find f dash x, so the derivative of f of x, for f of x equals x squared plus 2x using first principles. Yeah, we'll write down the formula. So the derivative equals the limit as h approaches 0 of the gradient that connects the chord. That. Now you don't know yet what f of x plus h is, and you don't know yet what f of x is. You gotta figure it out. Oh, you know what f of x is because it's written right up here. So it's really probably a lot easier than it really seems. We're just going to sub x plus h into where all the x's are. So we get x plus h squared plus 2x plus h. And we're going to take away f of x, which is that function. Make sure you put it in brackets because that negative is going to influence both of those terms. All over h.
I didn't understand that last. X squared plus 2x minus f.
This is minus f of x, and f of x is this.
And we said, where did you get the x plus h squared and the 2x?
This is this bit here. So all we're doing is subbing in x plus h into the function where the x's are.
Okay.
So this x squared is now x plus h squared, and this 2x is now 2x plus h. Right? Okay, and then all you got to do is a bit of expanding and simplifying. This is probably where it gets the trickiest because you got to be careful. So let's go through it. Limit as h equals 0. So we get x squared plus 2hx plus h squared. So that's the first term. We get 2x plus 2h. We get minus x squared minus 2x. All over h. Just be very careful when you expand out your brackets. Now we cancel down. We've got this x squared and this x squared cancel. We've got this 2x and this 2x cancel. And that looks like about it for now. Yeah, we can cancel down our h's as well. So we'll get rid of this h, one of those h's, and this h. So we're left with 2x. We have 1h here. We have a 2 here. And that looks like about it. And no h on the bottom. Did I miss something?
No, you're saying when you make h equals 0.
Ah, right, yeah. Yeah, so now we just, as h approaches 0, so we sub in h equals 0. So that equals 2x plus 2.
Do we have to write
Wait,
f
why?
of
Where do you get the plus 2 from at the end?
That is this one here.
Is that 2 times 0?
No,
We're not subbing in 0.
we're just cancelling the h's. When you cancel all the h's, you replace them with 1s.
I'm
Yes?
still a little bit confused. In the second line, we've got x plus h squared plus 2x plus h.
Okay.
I understand the bit on the right. But not that.
Yep, so this bit comes from here. So that's just like right back to the first like notation we did of f of x. You know when you write f of 2 and you sub in 2 where all the x's are?
Yeah.
It's the same thing. So if you've got f of x
Okay.
plus h, you just sub in x plus h to where all the x's are in the original function. Yeah, that's all it is. Okay, so we get the derivative of this function here, x squared plus 2x, is 2x plus 2.
How do you write that?
Sorry?
How do you write that?
What? These are all like this.
What happens to that 3y over here?
That's only if it's in terms of like y equals x squared plus 2x. Our question is in f of x, so we write f dash x. F.
And you always use the bit at the top, x plus h minus f of x over h. Is that what?
That's the general rule, yeah.
Okay.
That is first principles. Anytime something says first principles, it's that formula that we first used. Okay? Okay, let's try one on your own. All right, find the derivative of that function using first principles. When you expand out those two brackets, make sure you keep it in a bracket because you've got that negative in front. It's going to influence everything inside it. Just keeps going. Okay, so basically that negative is going to make everything in the bracket a negative, so I'm just going to change it all. That negative, that negative, that negative. No, because you just got -1 in front of the bracket.
Oh, it's 2 minus. Okay.
2 minus, yeah. No, ooh. So minus. Yeah. So it's like 2 minus 1 times the bracket. Okay, cancel down. What have we got? This one and this one.
Minus
2 and 2. Got
h squared x minus 2h squared x.
h squared x
Minus 2h squared x.
2h squared x. Yeah, so we got well, that'll make negative 3h squared x. Do we have anything that completely cancels out? No, because they're all negatives. So I'm going to rewrite it. So we've got negative 2hx squared minus hx squared. So that one and that one make, oops, write out the whole thing. So they make negative hx squared. I got this one and this one make negative 3h squared x and minus h cubed. So you might want to do that as well. I like to cross out each term as I simplify it just to make sure I've covered every term, because you don't want to accidentally leave one and not rewrite it in the next line. Okay, going to cancel down our h's now. So I've got one h on the bottom, this h up here, cancel out one of those h's and one of those h's. So I'm left with negative 3x squared minus 3hx minus h squared. Okay, sub in h equals 0, and that gets rid of the last two terms. We're left with negative 3x squared. Lovely. So eventually what you get, if you do that with every basic term, if we have f of x equals x, and you do it all by first principles, you can do that at home if you want to, what you actually find is you get the derivative equals 1. If you have f of x equals 2x squared, you find that the derivative equals 2x. If you've got x cubed, you find that the derivative equals 3x squared. If you've got x to the power of 4, you find that the derivative, whoops, don't be crazy, you get 4x cubed. Can we see a pattern forming? What you see is that you take the power up here, you multiply it down by what's in front of the x, in this case it's a 1, and then you minus 1 from the power. So we take the 4 down, so you get a 4 in front, and you minus 1 from the power, you're left with 3. So what would x to the power of 5 be?
5x to the power of 4.
Exactly, yeah. 5x to the power of 4. So here's the general rule. if f of x equals k x to the n, then the derivative equals k times n times x to the power of n minus 1. So that works up the top here because that x is actually x to the power of 1. So you take the 1 down, you minus 1 from the power, so you get 1 x to the 0. What's x to the 0? 1. So it's 1 times 1. 1. Right? And it holds for any constant number as well. So if f of x equals 4, that's the same as 4x to the 0, right? Because x to the 0 is 1. 1 times 4 is 4. Yeah, so if we follow that rule, we take the 0 down, multiply it by 4. We get 0 times 4, x to the negative 1. Anything times 0 is just 0. So the derivative of any constant number is just always 0. So the derivative by constant, I mean just a number. Could be 4, could be 5, could be 32, could be 108. Any derivative of a number is 0. So if f of x equals 3x to the 7, what's the derivative?
21 x to the 6.
Yeah, 21x to the 6. Take the power down, multiply it by what's in front, and minus 1 from the power. Pretty easy trick, right? So that means you can bypass all of first principles and just go straight to that trick.
That's where it came in handy for the first question.
Yeah. So no more expanding, no more simplifying fractions. If a question asks you to do it by first principles, that's when you need to know it.
Would that be in the test?
Most likely. Yeah. Now, here's another rule. If f of x equals g of x plus h of x, then the derivative of the function f equals the derivative of the function g plus the derivative of the function h. Sounds kind of scary. Actually, not at all. So if f of x equals x cubed plus 2x, all that rule is saying is that if you've got two terms added together and you want to find the derivative of the whole expression, you just take the derivative of each term. So f dash x, what's the derivative of x cubed using that rule?
3x squared.
Yep. And what's the derivative of 2x?
1.
2.
This has got a 1 up here.
0.
No.
2.
Take the 1 down, multiply it. Minus 1.
X is 2.
It's 2. Yeah. You'll soon realize that, like, if you've got any term with like 2x or 3x or 4x or 5x, the derivative is just the number that's in front, the coefficient. So that's all that rule means is if you want the derivative of a function that's got more than one term in it, you just find the derivative of each term. Okay. Let's try another one. if z equals 3x squared plus x to the power of 5, find the derivative. First, it's not f of x, so how would you denote the derivative? dz dx. What's the derivative of 3x squared?
3x to the power of 1.
6x to the power of 1 or 6x? Yeah, take the power down, multiply it, minus 1 from the power. And what's the derivative of x to the power of 5? Yeah, 5x to the power of 4. Yep, that's my answer. That's the derivative. Not that bad, right? Right, this one. Are those terms in the way that we're used to? Ooh, go away. So, yeah, just expand the brackets. So everything times n. So we get 2n squared plus 4n plus 6n plus 12 10n plus 12. How do we denote the derivative?
dm
dn. What's the derivative of 2n squared?
4n.
Yep. 10n?
And
Yep. And the derivative of 12? Yeah. Derivative of any constant number is just 0. So that's final answer. Good time. Yep. In 15 minutes. We've got one more example, which is a bit trickier. So I think it's useful to go through it. Find the coordinates of the point on y equals x cubed that has the gradient of 8. What do you know about the gradient of a point on a curve? Exactly, it's the same as the derivative. So find the derivative of the function, which is x cubed, and it'll be the same as the gradient 8. First of all, it's y equals, so how do we denote the derivative? Yep. dy dx. What's the derivative of x cubed?
3x squared.
Good. We know that that derivative is going to be the same as the gradient because they mean the same thing. So we can say 3x squared equals 8. What does x equal?
Just make it twice.
You have to square it. You have to square it.
You have to do this one first.
Square root.
Remember, the square only applies to the x.
Yeah, but then you have
So-
to take the square root over.
Yeah, you do, yep. So you get plus minus 8 on 3. So we get plus minus root 8 on root 3. Yeah, so before we do that, we want to, what do you call it? Rationalize it? Yeah.
No,
So-
something last year. You times it by the third.
Yeah, so whatever third you've got on the bottom, you times it by that third on that third. So we just times by root 3 on root 3.
Yes.
Any fraction with a third on the bottom is not favourable. We don't like it. So to get rid of it, we multiply the fraction by the same third on the same third. So, yeah, so we get plus minus root 8 times root 3 is root 8 times 3. So 24 on root 3 times root 3 is root 3 squared. The root and the square cancel out. We get 3. Can we simplify root 24?
2 root 6.
Yeah. Yep. So plus minus 2 root 6 on 3. Okay. But the question says find the coordinates. We've only found the x coordinate. Sub it in, yeah. So y equals. We'll go with the positive first. Cute. So we've got also the negative one as well. Okay. Now what? So basically, yeah, you end up with yes, 16 root 6 on 9 and negative 16 root 6 on 9. So our two coordinates are just the positive x and the positive y, and the negative x and the negative y.